Assalamu alaikum, dear honorable lecturer, Dr. Adin Wanis bin Tismai, and my classmate. My name is Muhammad Muntasir Billah, together with my team members, Ruta and Joris. So I would like to give you thanks for giving us an opportunity to talking about our project. So in this presentation, we're going to talking about our final project, which is called GPU ray tracing. So in the stages, we are going to discuss about our project proposal, technique, initial algorithm, and UI UX design, development and implementation, and also the testing and evaluation performance. So for the proposal, we're going to create a program that demonstrates a difference between ray tracing and also the rasterizations. And it shows how each performs by using FPS frames per second. So for the methodology, we have evaluated several stages where we have ideations. And for the ideations, we just basically come up with an idea for our project, which is researching choosing techniques. And for the design, we are designing a scenes which will be used in our project. For development stage, we are writing a code and building a project. For the testing, after overall finishing our project, we are going to test the conductor to find or correct issue if there will be any. And for the evaluations, after finishing testing, the final project evaluation will be conducted. So this is in the figure, as you can see, this is our initial UI UX design. So here we have first idea for the menu that has included project descriptions, explanations how to navigate inside the scenes, and also the loop scene. So for the end scenes, the plan was to display average FPS, menu button, and also the exit button. So we planned in the main scene, display FPS counter in the upper right corner. And also it allow user to change quality detail, which are increase ray tracing, decrease ray tracing, and also turn off ray tracing. So for final UI UX design, as you can see in the figure on our right side, so where we have the menu, and where the user can choose between benchmark and free work scene. And also the user choose a graphic setting, which are low, medium, and high, and also the whether to use rasterization or ray tracing. For the benchmark scene, user can see FPS in the upper left corner, and camera moves through different rooms from different angles. So after the benchmark scene, user transfer to the scene with the average FPS displayed. So in the figure, as you can see, once the user has finished their walk through, and then they can see the overall average FPS. So this is where the free walk scene, where the user navigate the scenes himself. And for the controls, the user can use or press the WASD or any arrow keys for movement, and also for mouse for turning, steering the turning around. And user can see FPS in the upper left corner. I think that's all for me. And next technique and initial algorithm will discuss from our other members.
So talking about ray tracing, it's a method that's used to create visual images in 3D computer graphics. It's more realistic than, let's say, rasterization, raycasting, and scanline rendering, yet it uses a lot of resources. Next slide, please. As for algorithm, basically it works by tracing a path of an object visible on a virtual screen by following a line from an imaginary eye through each pixel. and it builds an image by extending rays into the scene and bouncing them off surfaces and towards sources of light to approximate the color value of pixels. Next slide. And moving onwards to development and implementation stage, in our project, we implemented such things as FPS counter, average FPS counter, also camera movement, and free walk. So for FPS counter, basically there's only like 2 lines of code. It's lines 15, 16 as can be seen. And the principle is that counter is divided by the time frame that passed between the current and the last frames. Next slide. For average FPS counter, it also uses the time frame and divides it, but unlike with FPS counter, the time frame is divided by the time scale, and it also uses only 2 lines of code. It's 18 and 19 as can be seen. Next slide. For camera movement, we use cinematic timeline instead of a main normal camera, and as can be seen when the project is running, the camera moves smoothly around the scene. Next slide. And for the free walk, a user can move around the scene by himself. Also, FPS is shown on the upper left corner. And as mentioned before, user can either use WASD or arrow keys for movement and mouse for turning around. Next slide. So this is our specifications of our computers. As can be seen, only one of them has RTX GPU, the other two uses different ones. And yeah, let's move on. So for testing and evaluation performance, so for testing, we tested application functionality, also benchmark performance, and we did the testing with different computers. Next slide. So these are results. Sadly, only 2 computers could be used for testing because the project uses a lot of resources, and for weaker GPUs, it's a challenge to open and run the project. And also from the results, it can be seen that the difference between 2 computers is more than 10 times. Next slide. So this figure shows the comparison between rasterization and ray tracing using computer with RTX GPU. It can be seen that the difference is quite huge, as we expected, although the difference between the high graphic settings is not as big as with the other settings. Next slide. And this is the comparison between 2 computers. And as I mentioned before, the difference is quite huge, almost 10 times, because the computer with the Radeon GPU, it's a weaker GPU, therefore the results are like that. Next slide. So moving on, for ambient occlusion, it's basically how light interacts with objects, and it can be seen that when when the rasterization is used, the shadows are quite soft, more natural looking, and with ray tracing, they're darker and less aesthetic and appealing to the eye. Next slide. For the reflections, it can be seen that with ray tracing, they appear in the puddle. The ball can be seen, and with rasterization, there's no reflections because it cannot do that. Next slide. And for global illumination, it's basically the main difference is that in rasterization, the shadows are softer, and in ray tracing, once again, they are more harsh, darker. And they're also in ray tracing, there's more light bouncing off surfaces. And it might look more realistic, but less visually pleasing. Next slide. So in conclusion, we deducted that rasterization is much faster compared to ray tracing, and even the RTX GPU was not enough to get playable results with the ray tracing on. Also, ray tracing might be more realistic, but in many cases it's less visually appealing, and scenes have to be adapted to using ray tracing. So that's all for the slides.
Okay, so now I'll do the demo presentation up with our project. So Montasser, if you can stop screen sharing, I will share my screen. So instantly a disclaimer, I'm using my computer remotely, which is in Lithuania. So the demo might look a little bit laggy. And I also want a confirmation from my team members if you can see the screen.
Yes.
Okay, so so first of all, I would like to say that we're using a project which is not made by us. It's basically sample project from Unity, which is called HDRP 3D Scene, which has HDRP, which also has ray tracing capabilities. So with HDRP, you can basically go through a wizard, which goes through all the settings which are needed to turn on to make ray tracing work on an RTX GPU. Sadly, other GPUs are not supported. Only RTX GPUs are supported in this project or in Unity overall. So I think let's go through the project. So I'll run it, and this is the main menu, which was presented earlier. We have a drop-down menu for choosing graphics settings. We also have buttons to turn on benchmark, also to turn on free walk mode or to quit the program. So let's maybe start from free walking. So with free walking, you appear in the scene. As I said, like it might look a little bit choppy because like I have big input lag, but this is right now with ray tracing. And yeah, basically you can, wait, is it with ray tracing? There's also spacebar button, which gets you out of the free walk mode. So I'll quickly just like get back into the menu. Yeah, the settings were high plus ray tracing. The default is high. I'll turn on lower settings so that it would run a bit smoother. So you can walk around the scene. As you see, like right now I'm getting more FPS, but yeah, it's a little bit choppy still from the input lag. Yeah, that's how this scene works. And we also have scene with benchmark, which is like more important for us at least. So we can choose the settings, and the benchmark will run for 1 minute. I think we might wait. I'm not sure. It will take 1 minute to complete the benchmark. We can make it as long as we want or as short as we want, but 1 minute is just going through all of these animations and all of these camera movements, which were implemented in this sample scene. So it's just like showing the rooms which are in this scene, yeah, and it shows you the performance when it ends. So actually the FPS gets slower when you use this benchmark thing, not use free walk. Hard to say why. Maybe camera movement adds a lot of stress to the components of the hardware, but hard to say. So let it finish, because the screen after this is the most important one, where we got the results. So yeah, it's already ending, and we get the average FPS. So this FPS was collected, and we put it into a table, which was shown in the slides. And then we can like present you the results of our ray tracing on, ray tracing off, different settings which were used. And yeah, one thing is I also think is important to mention is that how this works, how the ray tracing works and why does it work. So first of all, there were like setting presets created, and they're in project settings. So yes, if you can see here, there are like different quality settings, which are also in this drop-down menu. And in here, in the menus, you can modify each of those settings and turn on ray tracing. So for example, if I turn on high quality, and you will see that there will be real-time ray tracing preview and it's disabled. But if I check RTX high quality, it has ray tracing enabled. So that's how and why the settings change when you change the drop-down menu button. Yes, and also what was mentioned in the report, but probably not in slides, that our scene where you can walk, or the benchmark scene, it has in hierarchy, it has volumes, which basically means that every room is a box in which different lighting settings are used. So we didn't adapt our project to work on every room differently and behave differently, but we only changed the volume global object, which has all the settings with ray tracing, and it affects all the scene, not like one room, it affects all the scene. So it's at the same time good and bad, because for us it was easy to basically make the benchmarks, but what is like not very good, that we got, I would say, worse performance, just because like ray tracing is on all of the scene basically, and it's not very well optimized. So I think for the demo, that would be it. There are like a lot of settings to tinker with. I tried to be as simple as possible right now, just so it would be clear how everything works. But there are basically many settings we changed a bit, turn on ray tracing, and yeah, got the results. So I think I'll stop screen sharing, and I would like to thank everyone for attention, and that would be it from us.